Hi friends, today we're doing Unit 7, Lesson 1, the Sun, Earth, and our Solar System. We're going to start by going over some of the key vocabulary words that you'll be hearing in today's reading. Our first word is atmosphere, a blanket of gas surrounding a planet. Our next word is axis, real or imaginary line through the center of an object. Our next word is eclipse, an event that occurs when one object in outer space blocks the sunlight reaching another object. Our next word is hemisphere, half of the sphere of Earth. Our next word is universe, all objects of matter in space, including Earth and beyond. We are now going to move into today's reading. If you travel to another country and someone asked, "Where in the world is your school located?" you might answer by giving the school's address. Its address explains where your school is located on planet Earth. A mail carrier could find our school and deliver this envelope from anywhere in the world. But let's pretend you traveled far, far away to a distant place in outer space, and an extraterrestrial being asked, "Where in the universe is your school located?" How would you answer that question? You would need to give someone who lives far away from Earth more information as part of your school's address, a space address that explains where school is located on a map of the universe. The first part of your space address that you would add to the envelope is your planet, Earth. You might think you already know everything there is about Earth. After all, you've lived here your entire life. But what do we really mean when we say we live on a planet? The word planet means wanderer, a name ancient Romans gave to objects in the sky that appeared to wander on a different path than the stars did. As astronomers have continued to observe and study space with more powerful tools and learn more, they kept thinking about and discussing the exact definition of a planet. Scientists today classify a planet as having 5 important qualities. 1. A planet is a sphere or nearly round object in space that has a large mass. 2. A planet travels or wanders in a path called an orbit around a star. 3. A planet has cleared out most other objects from its path as it orbits around the sun. 4. A planet is mostly made of rock or gas or a combination of both. 5. A planet does not make its own light, but it shines in the sky because it reflects the light of the star it orbits. Planet Earth is made of rock and orbits a star you already know by name. Can you guess it? Earth's star is the sun. The sun, like all stars, is an enormous mass of incredibly hot gas. It creates a huge amount of energy in the form of light and heat. Earth is one of 8 planets that orbit the sun. You should remember talking about the sun in our light and sound unit. Actually, Earth is the 3rd planet away from the sun, 93 million miles away to be exact. That's a long way. If you drove from Earth to the sun in a car, going 60 miles an hour, or about the speed you might travel on a highway, it would take you almost 177 years to get there, and that's without stopping to stretch. Most living things on Earth need heat and light from the sun to survive. 93 million miles may seem far from the sun, but it's actually the perfect distance for human, animal, and plant life on Earth to exist. You can think of the sun's energy as being like the temperature of Goldilocks porridge. If the sun were closer to Earth, it would be too hot, so hot that Earth's water would boil away. If the sun were farther away, it would be too cold, so cold that all Earth's water would freeze completely. As it is, Earth's position in our planetary system is just right for life. In fact, Earth is the only place in our sun's system of planets, or in the entire universe, where we know life exists. Another reason life can exist on Earth is because of Earth's atmosphere. An atmosphere is a covering or envelope of gases that surrounds a planet. Earth's atmosphere traps the sun's heat, keeping it near the surface of Earth. This keeps Earth from getting too cold. Earth's atmosphere is all around us. Take a deep breath and hold it. You have just breathed in some of the atmosphere. Now breathe out. Your breath has just added something to the atmosphere. Besides providing the air we breathe, the atmosphere also protects Earth. Have you ever slathered on sunscreen to keep from getting sunburned when you go outside? Earth's atmosphere is like sunscreen for Earth, blocking some of the sun's harmful light rays from reaching Earth's surface. Earth's atmosphere also diffuses some of the sun's light. This is what makes the sky look blue. In images of Earth as seen from space, it's easy to see the blue of Earth's oceans. Water covers about 70% of planet Earth. That's a lot more than half the surface of Earth. Earth's water is essential to support plant and animal life as we know it. One moon orbits Earth many miles beyond Earth's atmosphere. Earth's moon is by far our closest neighbor in space, but it is still far away. Do you remember the line in the classic Mother Goose rhyme that said, "The cow jumped over the moon"? Well, that was one high jumping cow. The moon is about 239,000 miles away from Earth. So if the cow jumped from Earth to the moon going 60 miles per hour, it would get there in about 166 days. That would be one mighty jump for a cow. You have seen the different phases of the moon as its shape changes during a month's time. As the moon orbits Earth, we see different amounts of sunlight reflected from the moon's surface. Sometimes the moon, Earth, and sun line up so that one of them is hidden from view. This is known as an eclipse. A solar eclipse happens when the moon comes between the sun and Earth, hiding the sun so some people on Earth can't see it. A lunar eclipse is when Earth comes between the sun and the moon. When this happens, people on Earth see Earth's shadow on the moon, making the moon appear darker or even seem to disappear. But the moon doesn't really disappear. It's just hidden for a short time in Earth's shadow. Planet Earth moves in two ways. The first we've already talked about. It travels in a nearly circular path or orbit around the sun. The actual path of Earth's orbit is not a perfect circle. It is just a little longer in one direction than in the other. The name for this type of nearly circular path is an ellipse. An orbit that is shaped like an ellipse is described as an elliptical orbit. It takes Earth 365 and 1/4 days to orbit the sun one time. So Earth's year is 365 days. The amount of time it takes a planet to orbit the sun one time is called its planetary year. But what about the extra 1/4 day? Why don't we count it? Actually, we do count it. We just don't count it every year. Instead, we add up this extra 1/4 day for 4 years in a row to make one full day. Then in the 4th year, we add that extra day to the end of February, so once every 4 years it has 29 days instead of its usual 28. We call this year with the extra day a leap year because everything leaps ahead by one day. The second way planets in our solar system move is by spinning as they orbit the sun. Have you ever spread your arms wide and twirled around until you were so dizzy you could hardly stand up? Maybe you have played with a spinning top or have seen an ice skater spin quickly around and around on one foot. This is what it means to rotate. But when a planet rotates, it doesn't twirl around on feet like you do. It spins around an imaginary line that goes from its north pole to its south pole, right through its center. This imaginary line is called the planet's axis. One day is the amount of time it takes for a planet to rotate one time around its axis. A day on Earth is 24 hours. These 24 hours are divided into daytime and nighttime. As Earth rotates, half of Earth faces the sun and receives the sunlight. It is daytime on this side of the Earth, but at that same moment, the opposite half of the Earth is facing away from the sun. This side of Earth is not receiving any of the sun's light, so it is dark there. It is in the Earth's shadow. It is nighttime. We don't feel Earth spinning. From our viewpoint, it looks like the sun is moving and Earth is not. After all, doesn't the sun appear to rise every morning in the east and set every evening in the west? This daily motion of the sun from east to west might make it seem like the sun is moving around Earth, but it's not. You are moving around the sun, or really, Earth is. In the morning, the part of the Earth you are standing on is turning away from darkness and rotating to face the sun. When the sun is up at its highest point in the sky, Earth has rotated, so you are fully facing the sun. In the evening, Earth turns away from the sun and it becomes dark again. Why is it dark? Because you are in the shadow of Earth. It is night and you go to bed, but as you sleep, Earth keeps rotating on its axis, and before you know it, your side of the world will have turned to face the sun again. You and the part of Earth on which you live will have once again moved out of Earth's shadow. And you'll know that one rotation of Earth one day will have ended, and another one will just be beginning. Days turn into months, and months turn into seasons. Let's take a class poll to find out what season is the favorite. Remember, an axis is the imaginary line that goes through the center of a planet from its north pole to its south pole, and then points out into space in both directions. But a planet's axis doesn't always point straight up and down, like the axis of a spinning top. Many planets, including Earth, have an axis that is tilted a little to the side. This tilt is the key to understanding Earth's seasons. Because Earth is tilted, there is a time of year during Earth's orbit around the Sun that the North Pole, and therefore the whole Northern Hemisphere, is tilted a little bit toward the Sun. This tilt gives the Northern Hemisphere longer periods of daylight and shorter periods of nighttime darkness. Longer periods of daylight give the Sun more time to warm Earth, so it gets hotter. The tilt of Earth's axis also makes the Sun in the Northern Hemisphere appear higher in the sky at noon. When the Sun is higher in the sky, its rays hit more directly, at less of an angle. The more directly the Sun hits the Northern Hemisphere, the better job it does of heating that part of Earth. So it is the tilt of Earth which causes longer periods of daylight and a high noontime sun that makes summer happen. While it is summer in the Northern Hemisphere, let's see what is happening in the Southern Hemisphere. Why is it winter on this part of the Earth? The reason is, again, the tilt of Earth. When the Northern Hemisphere is tilted toward the Sun, the Southern Hemisphere is tilted away from the Sun. This causes the Southern Hemisphere to have shorter periods of daylight, and the Sun to appear lower in the sky at noon. Shorter periods of daylight give the Sun less time to warm Earth, so it is cooler. And when the Sun is lower in the sky, its rays hit Earth at more of an angle or a slant. This angle makes the Sun have to heat a larger area of Earth with the same amount of energy, and this means the Sun does not feel as warm. The rays of sunlight are less direct and less intense. It is colder, it is winter. As Earth continues its orbit around the Sun, the axis of Earth always stays pointed in the same direction. So when Earth reaches the opposite side of the Sun, the South Pole instead of the North Pole is now tilted toward the Sun. This means that the Southern Hemisphere has summer and the Northern Hemisphere has winter. The seasons in the Northern and Southern Hemispheres are always opposite each other. This is because only one of them at a time is tilted toward the Sun. So now you know the first part of your space address. Your school is on planet Earth, and planet Earth is part of your space address. So now you have more information that you would need to answer an extraterrestrial being that might ask you where your school is located in the universe. In the upcoming lessons, you'll learn more about your space address. You may now move on to Unit 7, Lesson 1, Google Form.